Welcome back for part 2 of our video on distributions and plots or something of that nature. Anyhow, now we're going to start looking at a box and whisker plot. Now a little bit of review. If you remember, your box and whisker plot is something that is set up to show the distributions of data. Your center two boxes here, that's going to be the center 50% of your data. The center or median is going to be this vertical line, and this whisker here is the bottom 25% of your data. This district here is going to be the top 25%. And when you add all those 25% together, that's going to be your spread to show 100% of the data. Let's take a look at this one and see what we can learn from looking at a box and whisker plot. First, we're going to notice that the left whisker is shorter than the right whisker, and that the line representing the median is also closer to the left than it is to the right. What does that mean? Well, that means that the data are going to be kind of bunched up on the left-hand side. That represents the peak is on the left and the tail is going to be to the right. So your peak of the data, the majority of the data is going to be over here on the smaller section left-hand side, but you're going to have that tail, that little bit of lingering small amount of data that goes way out here on the right-hand side as well. Keeping it going from there, we're going to take and look at how they can be skewed. First off, this one here, the left whisker is longer than the right whisker. The median is closer to the shorter whisker. So what do we have here? This is negatively skewed, also known as skewed left, where we've got this little bit of data that goes way out over here. But this short section, remember, this little bitty section represents half of your data. And of the middle two sections, this is 25% of the middle, and this is 25% of the middle. So the majority, or half of your data is in this tiny little section, and the other half is drug out here to this long side, meaning that once again, this is going to be skewed left or have a negative skew to it. The next one we're going to look at is one that's going to be symmetric. Here you can see that 50% of the data is on either side of the median, which is this vertical line. You can also see in the middle 50%, 25% and 25% on each side. Those sides are the same. The whiskers are the same. This is a perfectly symmetrical graph. And then we're going to look at a skewed right or positively skewed one. Here, the whisker to the right is longer than the whisker to the left. Once again, this tiny little section of these two parts here, that is half of your data is all bunched up in this small area. The other half of your data is drug out through all of these data points right here. Your median is off to the left of the center, meaning once again, over half of your data is over here. In the middle 50%, you have this section right here. That is 25%. That is the bottom 25 of the middle. Of course, this is the bottom 25 overall, but this is the lower 25% in the middle. This is the upper 25% of the middle, which means that this section here between 25 and 50% represents a lot of data in a very small space. This section, 50 to 75% of your data, is more spread out. It's the same number of data points that are in this one, but it's spread out over a lot larger range on the graph itself. Let's keep going. Now from here we're going to take and use our graphing calculator again to create a box and whisker plot of this data. Now I went ahead and I put in those data points in my graphing calculator already. So let's see if I can find that. That's going to be right here. So I have already put in all of those data points in my list one. We'll move this where you should be able to see it. Now what do we need to do? We need to set up our window. And for our window, if you go back and look at the data they gave us, my lowest point is 2, my highest point is 53. So I needed a data value that was lower than 2 and a data value that was higher than 53. So I picked 0 for my X minimum and 55 for my X maximum. I'm using intervals of 1. My Y value, I just left it -1 and 10. I honestly don't think it matters on a box and whisker plot what your Y values are, because Y has no bearing on this at all. From here, we're going to hit the Stat Plot button. So to do that, I'm going to hit the second, then I'm going to hit the, let's see, a second button. Oh, hold on, I need to get out of this. So first off, I'm going to clear out of here. Second quit. There we go. I'm going to hit my second button, and I'm going to hit the Stat Plot, which is this one right up here. And this time, once again, I'm still in list 1, so we're going to plot 1. It's going to be turned on. The next one, we're going to take and scroll down to the box and whisker plot, which let me show you a little better what it looks like when it's on clear. See, now when I have selected, you can see it is clearly a box and whisker plot. We're going to hit that. And then we're referencing list 1, so we're going to leave that as list 1. We got everything we need. It is time to graph it. And when we graph it, boom, that box and whisker plot looks like that box and whisker plot, more or less. Difference is this one is showing the outlier. That outlier 53, it went ahead and separated it from everything. The one the calculator gave us, it did not separate the outlier from everything. It just ran that whisker all the way out there. Now, if you want to know what the data values represent, I should have showed you this on the last graph, but I didn't. You can hit the trace button, and you can see right here where it says trace. If I hit trace, where that star is going to show me what it is. Now you can see right here, the star is in the middle, and right here it says that represents the median or middle data value. If I go one thing to the left, that shows that Q1, the lower quartile, is at 10, and my minimum value is 2. Going the other way, Q3, my upper quartile, that's going to be 20, and then my maximum value is 53. All these data things you can find just by using the trace button. That shows you how to do this using the graphing calculator. Next, we're going to learn how to do this using the Desmos calculator. Alright, so I've set up our same list in my Desmos graphing calculator. And remember how to do that. You can hit the plus sign, you can hit the table, and after you do that, you just need to start typing those down in your X1 category. Now I need to add the graph itself. So once again, I've hit the plus sign, and this time I'm hitting the function button. And I'm going to go over here to the right hand side where it says functions, and I'm going to scroll down under visualizations, and what do you see right here? Box plot. So I'm going to select my box plot. What box plot data value am I using? I'm using the X1 right here. So in my parentheses, I'm going to hit X. I'm going to hit the shift and underscore. That allows me to get my subscript and 1, and that is going to give me my box plot. So now we can take and look at it on our graph, and once again you can see your least data value is going to be at 2. Your median is at 15, your lower quartile is going to be at 10, your upper quartile, that's going to be at 20, and your maximum value, where's that maximum value? Well, let's see. There it is. The Desmos calculator recognized the fact that 53 was indeed going to be an outlier. Let's take and zoom that in for you a little bit there. So you can see 53 is in fact going to be an outlier. So it put a dot way out there at 53. And when you take the outlier out of consideration, what do you see in the data? I see a symmetrical graph. So if I was to look at it using the box and whisker plot on Desmos, I'm going to say that I have a very symmetrical graph with one outlier, 53. But if I was to take and look at that calculator, that same data, on my graphing calculator right here, I would say I don't have a symmetrical graph. I'd say I have one that's skewed to the right or skewed positively, and that the majority of the data values are going to be in this section over here. That's not necessarily accurate. That shows what kind of effect an outlier is going to have on your data. So let's jump back over to the lesson and see what else they've said. They went ahead and gave us some instructions on how to take and put all this stuff in their calculator. I'll put that up there for you. If you're using the graphing calculator, I really encourage you to use the Desmos one. It's just so much easier to use. It really is. It distributes your data better. Right here it says the lengths of the whiskers are approximately equal. The median is in the middle of the data, and this indicates the data are equally distributed, and the left and right of the median, thus the distribution is symmetric. Now I had noticed that the calculator that they showed us right here had the outlier listed. So I said, I wonder if our calculator would do that. And the answer is yes, indeed, it will. And this is how I did it. I hit the second button and went to stat plot. I hit 1 for the plot 1, and then under the type, instead of doing this one, I did the one next to it. Because if I hit that one, you can see better the one next to it. It has the little dots, and those little dots represent the outlier. So I'm going to hit that one, and then when I hit my graph button, boom, it's going to show me you have the box and whisker plot is basically symmetrical, and then you have this one outlier right here. So the handheld graphing calculator will also show you how to graph these both with the outlier included in the data set and separating the outlier from the data set. Pretty handy things to know. Quick little study tip. It says in example 2, notice that the outlier does not affect the shape of the distribution. That's because they pulled that outlier out. If they had left the outlier in the distribution, it affects the shape of it greatly. And also point out in their instructions, they showed you select the box and whisker that has the two little dots on it to separate that outlier from it. Let's keep going. Analyzing distributions. You've learned that the data can be described using statistics. The mean and median describe the center of the data. The standard deviation and quartiles describe the spread of data. You can use the shape of the distribution to choose the most appropriate statistics and describe the center and spread of the data set. This is where things start getting a little fuzzy, so you really got to pay attention to the finer details of when they're saying you're going to be using each one. So I'm going to go on to the next shot. It says when the distributions are symmetric, the mean accurately reflects the center of the data. So if you have a symmetric distribution like this, you're going to want to choose the mean. From here, if the distribution is going to be skewed, this statistic is not going to be reliable. So if you're going to be skewed one way or the other, then using the mean is not going to be a good measure of central tendency for you. So from there, we're going to say in lesson, which we didn't do this lesson, but you should know, we have discovered that outliers have a strong effect on the mean of the data. We saw that in the previous graphs we looked at with and without the outlier, while the median is going to be less affected. So when the distribution is skewed, the mean lies away from the majority of the data towards the tail, and the median, less affected, is going to stay towards the middle of that majority of the data values. So here we have a negatively skewed graph, and you can see how it took the median middle number and left it over here, but because you have these negatively skewed, it drug the mean way down there to the left. That's kind of a problem. Likewise, if we have a positively skewed, the mean's going to be the middle, the median's going to be the middle data value, but because you have all these numbers over here to the right, the mean got pulled off to the right as well. When choosing appropriate statistics to represent a set of data, first you need to figure out the shape of the distribution. If it's symmetric, you're going to use the mean. If it is not symmetric, if it's skewed, then you're going to end up using the median. If the distribution, that says right there, to use a mean for the symmetric, and boom, if it's skewed, we're not going to use a mean. In fact, they said what we're going to use is a 5-number summary. So what's a 5-number summary? Well, we're going to find out. Keeping it going here. So here we've got a whole new set of data, and we're not going to take and graph this because there's no reason to. They've given us everything we need right here. It says describe the center and the spread of the data using either the mean and standard deviation or a 5-number summary. Justify your choice by constructing a histogram of the data. So they typed all their data values into their graphing calculator, they created a histogram, and then they said, well, what does our histogram actually show? And it says the graph is high in the middle, it's low on the left and the right, therefore the distribution is symmetric. Does it have perfect symmetry? No, it doesn't. But it's pretty dang close. And because it's pretty dang close to having symmetry, symmetry, we're going to take and we're going to use the mean and the standard deviation to represent the spread of our data. Now off the side it says, remember on a graphing calculator, each bar is called a bin. I honestly did not know that. And the width of the bin in each window can be adjusted by pressing the window button. I did show you all that. That became the XSCL, and then hit view the histogram in different bin width to compare the results to determine the appropriate bin width. So bin width of 1 probably isn't going to get you what you want on a histogram. You're going to need to clump your data together in groups of 5 or 10 or something of that nature. Now jumping back over here, we had said that it's symmetric. That means we need the mean. If you remember, we have the X with the line above it. That's your mean of your data put right here. It also says that we need to use a standard deviation. What was the standard deviation? That's going to be this 7.1 right here. So the calculator found all that information for us. To find that, remember, you're going to hit stat, you can hit the right arrow, and then you hit enter, and let's keep it going here. The mean, as I said, was about 26.1, and the standard deviation, as I said right here, that's going to be about 7.1. There is no calculations you're going to have to do on these. The calculator is going to give you everything you need. You're just inputting the data and then interpreting the data that the calculator gives you. Now I just realized this video is getting pretty long-winded, so we're going to cut it off here and come back for part 3, where we're going to work this problem and see how we can use a box and whisker plot to interpret this data as well. And this time we're going to learn about the 5-number summary, to which the box and whisker plot does a magnificent job of giving us that information. So I'll see you in video 3.